Okay, we are at the Georeference box in our flowchart. In this video, we are going to take the map that we scanned and convert it from scanner coordinates into GIS coordinates so that we can use it as a backdrop for our on-screen digitizing exercise. It also means that any other maps, GIS maps over our field area, are going to overlay it. Now we do this by matching the corners of the clip region in the scan to the corners of the same clip region in the QuantumGIS map. Now the easiest way for me to show you this is to look at the instructions in the text and just go through them step by step. Okay, step 1. From the raster menu, click on the Georeferences submenu until the Georeferencer dialog appears. Step 2. Open the raster file called Yarmouth Land Use Interpretation.jpg. It's obviously a JPEG file. As an aside, I want you, as you're opening this, to have a look through all the image types that can be opened from this dialog. There are around 40 or 50 image types, so it is really unlikely that you'll ever have problems opening any image that you need to rectify. Now, earlier in this lesson, I suggested that whenever possible, you should use JPEG or TIFF files. And I say this basically because you're a lot less likely to have problems with these file types than any others. Anyhow, click on that file and it will open. Okay, we're up to step 4. This is where we specify the GIS coordinate system that our scan will be in following the georeferencing process. It is important that you choose the same coordinate system that all our other GIS maps are in. And that coordinate system is the NAD 83 ESPG 26986 Massachusetts Mainland Coordinate System. Quite a mouthful, I know, but it's very specific to our field area in terms of there's a whole bunch of other maps in the dataset and in future lessons that are all in this coordinate system. So I'd really like them all to be compatible with each other. Now the easiest way to find this coordinate system is to filter for it. So all you need to do is to type in, well, even MAS, MAS, the first few letters of the coordinate system, and you should see it in the list. Now whatever you do, don't choose the HAN system or the NAD 2011 version of the coordinate system. They are different coordinate systems, and once again your maps will be incompatible with other maps in the teaching data set if you choose to use that coordinate system. Okay, step 5. Click OK and the scanned image will display in the Georeferencer window. Okay, we're up to step 6. Right, I want you now to open the Land Use Interpretation Clip Region shapefile from the GIS for Beginners Digitizing folder. Okay, so then from the Layers panel, either double click or right click on the map to bring up its layer properties. Now I want you to change the fill style to be no brush and the border color to be pink. Now I say pink because through my experience I've found that pink is a color that provides really good contrast to other colors that you commonly find in GIS maps. So in other words, if you chose green, it would get mixed up with it'd get lost in vegetation, and if you chose a browny color it would get lost in urban areas and so forth. So pink is just a really, really good color. Okay, so we've now got the scanned version of the interpretation that we scanned opened in the Georeferencer window. Now note that the scan incorporates the clip region that we also have opened in the GIS, in the QuantumGIS map window. So these two clip regions are identical, but in the QuantumGIS map window, it's actually a GIS map. Okay, so our interpretation is in scanner coordinates and we're going to put it into GIS coordinates by matching the corners of the clip region in the scan to the same clip region corners in the GIS map. Okay, let's add our first ground control point. So I want you to zoom into the northwest or the top left corner of both the scanned image and the clip region that's in the GIS window. Now in the Georeferencer window, click on the Add Point button to add the first ground control point. Now I want you to get right into the corner, and that's why we're zoomed in. The more accurate you can get with this, the better. Okay, click on the corner in the scan with your left mouse button. And although we could type in the GIS coordinates of the corners in the clip region if we wanted to, we can also get those coordinates directly from the map canvas using our mouse. And that is usually a much easier way to go about this. So click the From Map Canvas button and get right into the same corner of the clip region map and click on it with your left mouse button, and voila, it's brought those coordinates in. So go OK, and there's our first ground control point. We can see that we have a dot on the image, and we also have a dot on the GIS map. So second ground control point. Now I want you to drag the photo across to the next place where we want to enter a ground control point. I'm going clockwise so I can be systematic. Now, being systematic is a really, really good GIS practice because you've got a much, much better idea of where you've been. Okay, second ground control point from the scan and matching ground control point from the map canvas. Get it as accurate as you can. Here we go. Click and it's in. Go OK, and we can see the dot in that corner and the dot in that corner. Third ground control point. Now drag your maps to the next ground control point area. Click on the Add Point button again, put a dot in this corner, and to take it from the map canvas, that looks pretty good. Go OK, done. Fourth ground control point. Now drag your maps to the next ground control point position. Now we're going to put our final ground control point in. Take it from the map canvas, that looks pretty good. Alright, so now we have our 4 ground control points, and we can see them if I click on this button here. We can go 1, 2, 3, 4. So we're in business and ready to go to the next step in this process. Okay, we're at step 7. Let's talk now about the ground control point table, otherwise known as the GCP table. Now, if we accidentally put a ground control point in the wrong spot, we can easily turn it on or off by toggling the visible checkbox. And if we toggle it off, QGIS will ignore it. Notice that the ID starts from 0 and not 1. That's because in most computer applications, numbers start from 0. The source X and source Y columns are the pixel coordinates of each control point in the scan. So the source X for ID 0, i.e. the top left corner, is 138.886 pixels in the X and minus 171.44 pixels in the Y. And what that means is that 0x and 0y in pixel coordinates are the top left corner of every scan. The dist X and dist Y stands for destination X and destination Y. These are the GIS coordinates for each control point in the Massachusetts mainland coordinate system. In this case, for ID 0, 305 484 is the X coordinate of this dot up here, and 823041 is the Y coordinate for the same dot. The DX pixels and DY pixels column represents the error in your ground control points. Low numbers in these columns, like 2, 3, 5, maybe 7, are good. but high numbers like say 20 or more are bad, so you should revise your ground control points in such cases. Now sometimes error values will remain high whatever you do, so on some occasions you may need to repeat the georeferencing process using the output from your first georeferencing attempt as the input for your second attempt. And sometimes it can take 2 or 3 or 4 goes to get this right. Now, the residual error is the overall error of a ground control point. Now, because we have the same clip region in both our scanned interpretation and in our GIS, we have very well defined ground control points, and consequently we have low error values. In other applications where you're using landmarks such as road intersections and things like that, and fence lines, these values are actually rarely as low as this, very rarely. Okay, so we've got our first 4 ground control points in both the Georeferencer window and in the QuantumGIS map window. Step 8. Now click on the green arrow button to start the Georeferencer. Step 9. The first thing that comes up is a message that says, please set the transformation type. Now, the transformation settings dialog box looks a bit tricky, and to be honest, it actually sort of is. That's because the options in this box allow you to customize your transformation type to the level of distortion within your scan. However, for our purposes today, all I want you to do is to set the transformation type to be polynomial 1, set the resampling method to be nearest neighbour, set the target SRS to be NAD 83 ESPG 2926986 Massachusetts Mainland Coordinate System, enter Yarmouth Land Use Interpretation underbar rectified.tiff as the name of the output raster, and make sure the Load in QGIS when done box is checked. Then click OK. Now, this doesn't take long at all. In the layers area, let's drag the image to the bottom and the clip region to the top. And when we do that, we can see that the clip region overlays precisely. Okay, so now we have a georeferenced image and we are in a position to on-screen digitize our land use interpretation. I will see you in the next video.